Average values describe the location of processes. 3 important average values are presented in this lesson. And hello again to this lesson, which essentially has 2 learning objectives. At the end, you should know the arithmetic mean, the median, and the mode. Furthermore, you should know that mean values are used to describe the process location. This lesson is divided into 2 chapters. In the first chapter, we look at 3 important averages and talk a little bit about the pros and cons. In the second chapter, we then get to know the mean as a measure of the position of a distribution. Let's start with the 3 mean values. Probably the most well-known mean is the arithmetic mean. The symbol for the arithmetic mean is an X with a horizontal bar above it. It's pronounced X bar. The mean value of a set of finite numbers is calculated from the sum of the values divided by the number of values. In order to be able to determine the median, the values must first be lined up according to their size. The median then separates the values ranked by size in half. It separates the higher half and the lower half of a set of values. The median can be thought of as the middle value. When calculating the median, however, 2 cases must be distinguished. Once an even number of values and once an odd number of values. If the number of values is odd, the median is actually the value in the middle. If the number of values is even, the median must first be calculated. The symbol for the median is an X with that wavy line above it. This line is called a tilde. The mode is the value that appears most often in a set of data values. The mode does not have its own mathematical symbol. As we will see in the second chapter, individual values can all be different. However, as a group, they tend to form a pattern known as a distribution. This distribution can be described by its location and spread. The location is described by a typical value that represents all values as best as possible. Either the arithmetic mean or the median can be better suited for this. Let's take a look at the average income of 10 people as an example. 9 people earn 1,000 euros a month, and 1 person earns 100,000 euros a month. The mean value is 10,900 euros. Next, let's compare this value to the median. If you take the median to calculate the average income, then you get a value of 1,000 euros. If 9 out of 10 people, that is 90%, earn 1,000 euros a month, then an average monthly income of 1,000 euros is more representative than 10,900 euros. In this example, the median is more representative than the mean value. The arithmetic mean can be sensitive to outliers. It is therefore necessary to consider carefully which average value best represents a group of values. At the end of this chapter, let's briefly summarize the 3 presented average values. From a set of finite numbers, the mean is the sum of the values divided by the number of values. The median is the value separating the higher half from the lower half of a set of values. And last but not least, the mode is the value that appears most often in a set of data values. It has already been mentioned that individual measured values can all be different. However, as a group, they tend to form a pattern known as a distribution. For example, the Gaussian distribution. This distribution can be described by its location and spread. The location is described by a typical value that represents all values as best as possible. Let's take a closer look. Let's take the diameter of this piston as an example. Its nominal diameter is 60.1 mm. This is a so-called variable characteristic. All values in between are therefore possible. Of course, this also depends on the accuracy of the measuring instrument. This histogram now shows how often a measured value occurs. It's visually obvious that the value 60.1 mm occurs most often. The arithmetic mean is also 60.1 mm and thus represents all values very well in terms of their location. The mean describes the size that is theoretically most commonly manufactured within tolerance. Mean values are used for many calculations within the framework of statistical process control. For example, the mean is used to calculate the process capability index CPK. Also, the mean or median are monitored by control charts. And the mean is used to calculate the systematic measurement error of a measuring instrument, to name just a few examples. So, mean values play an important role, which is why it is so important to know them. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the three most important key messages. Averages are a measure of the process location. Averages describe the size that is theoretically produced most often. From a set of finite numbers, the mean is the sum of the values divided by the number of values. The median is the value separating the higher half from the lower half of a set. And the mode is the value that appears most often in a set of data values. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care, and see you next time. Bye!